Alright, Chapter 4, Inequalities, Absolute Value. For 1, solving linear equations. Solve a linear equation to find the maximum number of ride tickets you can buy. Inequalities such as x is less than or equal to 1 and p minus 3 is greater than 7 are linear inequalities in one variable solution. A solution of an inequality in one variable is value of the variable that makes the inequality true. For example, 4x y 0, 7 are a solution 4, 0, and 0, 7 are a solution that x is less than or equal to 1. Two inequalities are equivalent if they have the same solution. The following properties can be used to solve inequalities by creating equivalent inequalities. Properties, inequalities, right? Equivalent inequalities. Add the same number to each side. Subtract the same number from each side. Multiply and divide each side by the same positive number. Multiply and divide each side by the same negative number and reverse the inequality sign. So on multiplication and dividing each side by the same negative number, reverse the inequality. So if you have a negative number, you're going to want to reverse the sign. Graphing inequalities. Graphing inequality, one variable consists of all of the points in a real number line of the solution and inequality. To graph an inequality, one variable uses the open dot is for less than, greater than, or a solid dot for greater than or equal to. For example, x is less than 2 on the left, and x is greater than or equal to negative 1 on the shown on the right. For 2, linear equations of the two variables. Solve graphic linear inequality of two variables. The linear inequality of two variables inequality can be written as these forms A, where A, B, and C are constant. AX plus BY is less than C. AX plus BY is less than equal to C. AX plus BY is greater than C. AX plus BY is greater than equal to C. An ordered pair X and Y is the solution of the linear equality of the inequality of the true, whether the X and Y are substituted into the inequality. For example, 4 and negative 1, one solution give you of 2x plus y becomes 2 times 4 plus 1 is greater than 5. So we'd have 8 minus negative 1 would be 7, a true statement that negative 7 or 7 would be larger than 5. Alright, graphing linear inequality. The graph of linear inequality, two variables, all solution of the inequality. The boundary line inequality that provides a coordinate plane in two halves. One half plane should be which is shaded contains the points of the solution inequality. The other half of the plane is not shaded, contains the points that are not solutions. Graph of the boundary line inequality with the dashed line x is greater than or less than. A solid line for greater than or equal to or less than or equal to is a solid line. Step 2, test the point on the boundary to see whether the solution of the inequality, then shade with the appropriate half plane. Alright, 4.3, system of linear inequalities. Goal, graph right and use system of linear inequalities. System of linear equalities, two variables, constant, two or more linear equation system variables. Example shown as x plus y is less than or equal to 2, and 4x minus y is greater than 3. Inequality 2. A solution of the system linear inequality is an ordered pair that is the solution of the inequality of the solution. The system has above 3, negative 2 as one solution. Graphing a system. Graphing of a system linear equality show the solutions of the system. Following methods of the graph. Graph the boundary inequality for the dashed line and the inequality for the greater and less than. Use a solid line for an inequality that's greater than or equal to or less than or equal to. Shade of the half plane inequality is greater than the system and is a region common to all half planes. The purple region shown as x is greater than less than 2 and y is greater than or equal to negative 1. You could use similar some system of linear inequality to describe real life situations shown in the following examples. 4. Solving absolute value equations. Solve and write absolute values in one variable. Absolute value of a number is written as x in a parallel line. The distance of the number is from 0 from the number line. Because the distance are always positive or 0, the absolute value number cannot be negative. The absolute value of x can be defined algebraically. X is a positive number. The absolute value of x is equal to x. If x is 0, then the absolute value of x is 0. If x is a negative number, then x is equal to the negative x. Absolute value of the equation. If x is a negative number, then avoid errors. The negative x represents the opposite of x. When x is negative, negative x is positive. So, absolute value equation for the absolute value of x is equal to c, where c is greater than 0. You can have two possible values for x that makes the statement true: a positive value of c and a negative value of c. For example, x equals 0 so solutions are 4, and negative 4 because 4 is equal to absolute value is 4, and the absolute value of negative 4 is 4. Solving the absolute value equation. The absolute value of equation A, absolute value ax plus b is equal to c, where c is greater than 0. The equivalent compound statement is ax plus b is equal to c, or ax plus b is equal to negative c. And you solve the equivalent forms and solutions. For example, x plus 4 equals 7. So there are 3 and negative 11. Alright, solving absolute values and inequality. Solving the graph absolute values and inequality. Exercise 46 and 47, solve the inequality defining frequency range of visible lights. The absolute value inequality has one of one of these forms. Absolute value ax plus b is less than c. The absolute value ax plus b is less than equal to c. Ax plus b, the absolute value ax plus b is greater than c, and the absolute value ax plus b is greater than or equal to c. Graphing inequality of the absolute value inequality involving less than or less than equal line segment with open solid dots and endpoints. For example, absolute value x is less than or equal to 3. This means negative 3 is absolute is less than equal to x, and x is less than or equal to 3. Graph shown below. The solid dots or endpoints indicate with the negative 3 and 3 are the solution of the inequality. Graph of the absolute value inequality involving greater than or equal to 2 rays opposite direction, opposite solid dots and endpoints. For example, x is the absolute value. X absolute value is greater than 4. Means x is greater than less than negative 4, or x is greater than 4. Graph is shown below. The open dots endpoints indicate that negative 4 and 4 are not solutions of the inequality. Solving the graph complex absolute value inequalities, you write to solve an equivalent compound inequality that does not use absolute value as shown below. So an inequality with the equivalent form, the absolute value ax plus b is less than c, is the equivalent form of the negative x is less than ax plus b less than c. Inequality square root of ax plus b is less than or equal to c. Negative c is less than ax plus b less than c. Absolute inequality, the absolute value ax plus b is greater than c. Ax plus b is less than negative c, or ax plus b is greater than c. In ax plus b, the absolute value ax plus b is greater than or equal to c. Ax plus b is less than negative c. Ax plus b is greater than c. 4.6 Absolute value functions. Evaluate graph use simple absolute value functions. The absolute value can be identified algebraically. Absolute value x is if x is positive, and if x is 0, and if and if x is negative. Graph of the absolute value of the y is equal as the absolute value of x if v-shape and consistent with the two rays that have the common endpoint at the origin. The common endpoint of the called the vertex of the graph. To the left, x is the common endpoint is 0 to 0. Note that the y is equal to the absolute value of x if the symmetrically with the y and because of each half of the reflection other than yx. For every point x and y on the graph, the point negative x, y is also on the graph. Graphs of absolute value. Graph of the y is equal to the absolute value of x is symmetric in the x-axis. The function helps graph absolute value functions in form as y is equal to a times the absolute value of x. Graphing the same function, use the information. If a is greater than 0, then the graph is open. If a is less than 0, the graph is down. If the absolute value of a is greater than 0, the v-shape is narrower than the graph of the y equals the absolute value of x. If the absolute value a is less than 1, the v-shape will be wider than the graph of the y is equal to x. Y is equal to absolute value of x. Chapter 4, Summary Review. We went over linear equality and one variable solution of an inequality and one variable graph of inequality and one variable compound equality, linear inequality and two variables, half plane, system linear inequalities, two variables, solution of system linear inequalities, graph of system linear inequalities, absolute value equation, absolute value inequality, and vertex. For 1 was solving linear inequalities. For 2, solving linear inequalities with two variables. Step 4.3 with system linear inequalities. 4.4 solving absolute value inequalities. 4.5 solving absolute value inequalities. 4.6 absolute value functions. Chapter 5 Quadratic functions and factoring.